morning.
Good morning.
Townsend. I was watching the video from class on Monday, and I heard you talking to Celeste about how you think my pictures are photoshopped.
I told you that to your face.
No, you did not. I was listening
well,
and I was like dying laughing. I was like, there's no way. Caught red-handed.
I don't deny anything I said. I would say, she told me you were supposed to be here, so I'd say if anyone was caught red-handed, it would be you.
No, I was still flying back at that time.
Okay, did you get to the questions like 70, like things or some ones on there?
I don't think it's really late.
Yeah.
Maybe once.
Yeah, I'm just not gonna have time to do it. So. Yeah. Yeah, I didn't even know that.
Blake Camden. Mason, Zoe Brady, William, Blake, Matt, Chloe, Hayden, Kate. Chloe made
Oh, we won conference. Good job. We stayed Monday and Tuesday. You guys might be actually. Pretty good. I got third in Wilson. Solid. I know.
Okay, I guess we're not doing the minute of silence today. Okay, I had 3 handouts for you guys to pick up, 39, 40, and 41. 39, we're going to quickly go over 3 more implicit differentiation questions. So that's the topic that we did last time. I just think it's good for you to force yourself to think about it a couple more times. Not that there's anything different about those, but all 3 of those questions on 39 are from past AP tests. So I'd like you to see that so that you can see that it does get asked pretty often and it gives you a good idea of what the difficulty level is. Then we're going to move into the other big topic in Unit 3. I told you there's a couple small things in Unit 3, but 2 big things.
Good morning, FHS. Today is Thursday, October 5th, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Okay, as I was saying there, Unit 3, the current unit that we're in has a couple small topics, but 2 big topics. One of those big topics is implicit, so obviously a little bit more practice before the next test would be good there. But generally you've seen what you need from implicit. And then the other big topic we will start with on assignment number 40 this morning, and it is on related rates. So the first 40 will be notes, and then 41 is a bunch of practice questions. Those typically take more practice to feel comfortable with than implicit. So we'll start that one today, but we won't be able to finish it. Okay, so again, I just kind of wanted to start off class this morning by talking about implicit one more time. And actually the idea behind implicit, all of the y prime stuff, does carry over into related rates, which is the other big topic. So I do think that this is helpful. Okay, so when I share stuff like this, I do try to show you like where it was from. So from 2000, FRQ number 5, the very first part, I cut all the rest of it off, but the very first part wanted us to take x times y squared minus x cubed y equals 6 and solve for the derivative. Now, the directions don't say anything about implicit, but as soon as you start to take the derivative of these parts, the second you take the derivative of y, you need a y prime, because we are taking the derivative with respect to x. So anytime we take the derivative of something that's not x, we need a y prime. So to do something like this, we have to use the product rule. So we could do the derivative of x with y squared left alone, and then x left alone times the derivative of y squared. What do you need?
If there's any more patty paper in the closet.
There is.
Oh, perfect.
Yep.
Thank you.
It should be the far bookcase against the wall, maybe second or third row up. I think.
Awesome. Thank you, sir.
Yeah. Okay, same thing over here. We would need product rule, but again, the more times you guys do product rule, the easier this should be. But we're taking the derivative of x cubed with y left alone, and then plus x cubed left alone times the derivative of y. So there was 2 times in there I took the derivative of y. Oops. But I have 2 mistakes here. So what is one thing that I didn't do? Okay, very good. This is minus all of this. So when you take the derivative, it's still minus all of that. You either need parentheses or distribute the negative before you don't forget. And something else. Right. You can't just take the derivative of the left side without taking the derivative of the right side. Now, as far as solving for the derivative, that's just going to vary question to question, but honestly, the messiness of these questions, in my opinion, is still easier than what you had to do in Unit 2. So I'd maybe take a step to distribute the negative, and anything without a y prime needs to move to one side. And that way, if everything on one side has a y prime, we could factor it out as a GCF. And then undo times with divide. Now, the last step here, I don't know how picky they are about this, to be honest. But I think you would be crazy to do all of this work, show that the derivative equals this, and let it not look exactly like that. So again, I don't know if it really matters, but I'm going to write this term first just because they did, and this term second. My answer, I'm missing a y here. So that is one nice thing about how they ask these in FRQs, is that they share the answer with you. I'm missing a y here, which means I should be missing a y here, which means I should be missing a y here, and here, and here. This y, I just didn't carry them down. So. But the most important part of this question is when I took the derivative of y here, I included a y prime, and when I took the derivative of y here, I took a y prime. That's what you need to solve for. If you forget that even once, then you can spend all day on that question and it's never going to work out. So, okay, you guys okay with this first one? Anything detailed you want to ask before we look at another one? I guess I will say also, last time I talked about, I've said this several times now, but FRQs are always scored out of 9 points on our AP exam, and we did look at one full FRQ last class where this was part 1, and I said it was worth 2 points. So generally they give you 1 point if you remember the implicit in each step, and then 1 point if the rest of your work shows and gets to the answer that they want. So that's only 2 of the 9 points, which is not significant. But that FRQ we looked at last class, I wanted you to see that parts B and C were kind of hard to figure out what they were asking. Calculus wasn't too bad, but it wasn't necessarily an easy question. And I did say it does get easier the more we practice it. But I didn't think to talk about, do you guys have any idea out of 9 points, like what an average FRQ score would be? Somewhere between 3 and 5 usually. Somewhere between 3 and 5 points is the average. So as hard as that FRQ was that we looked at last time, if you can go into it knowing that you can get 2 points from implicit, then that goes a long way to getting to the average. Our AP exam is scale scored, so just like the ACT. So if the average score is lower, you need less points to pass. And if the average score is higher, you need more points to pass. So, all right, so moving on, looking at 2001, and I didn't just like try to pick out the most recent or anything. I just picked random questions. So don't think 2001 was a long time ago. This may not be important anymore. It will certainly be on your AP exam. But this one doesn't say anything about implicit. It wants me to find this at this point given this information. So what is this? What are they giving me here? Okay, they're giving me the derivative, and they're wanting me to find second derivative at this point. So if we start to take the derivative, so this is y prime, so taking the derivative again would be y double prime. Looks like I need to use product rule here because I've got something times something. And when you take the derivative of y squared, you can do it just like the regular power rule, but you have to be careful enough to realize you just took the derivative of a y, so you need a y prime.
Would it be easier to distribute the y squared?
I don't know. It just depends. If you do distribute the y squared, you're still going to have to do product rule over here, so I don't know that it would be easier. So, derivative of the first with the second left alone, plus now the derivative of the second with the first left alone. Now, do I need a y prime on this piece? No, because I didn't take the derivative of y. Just because I have a y, I only include that if I have a y prime. Now, if the question said get this in terms of x and y's only, I could replace y prime with all of this mess, because this is what y prime is equal to. As far as trying to simplify this, there's really no need to, because this question, just like you guys should have noticed in your Khan Academy practice last time, if you're given a point just go ahead and start plugging the point in as soon as you've done the derivative. You don't have to clean this up at all, especially if you're plugging in a point. So everywhere there's a y, I'm going to put a 1/4. Y prime is not the same thing as y, so I can't plug a fourth into that. Everywhere there's an x, I'm going to plug in a 3. Now, if this was a calculator question, they're not going to be concerned about how messy this looks because you could always just throw it in your calculator. But this one was a no calculator question. But notice right here, I've got 6 minus 6. So do you see how all of this goes to 0? This goes to 0. And 0 times anything, all of that just goes to 0. 1/4 squared is like 1/4 times 1/4, which would be 1/16. So negative 1/8. Now for this question, we didn't have to do this, but I need y'all to know this just in case. All of this went to 0, so I didn't really care to plug in a number for y prime. But what if it didn't go to 0 and I needed to know what this number was? How can I figure out what y prime is at 3/1/4? You would need to plug it in up here. This is y prime. If you plug in 3 1/4 here, that would give you a number, and you could put that number there if you needed it. So again, that question didn't say anything about implicit, but there was one time I took the derivative of y, so I needed a y prime. We okay with that one now? Yes? Okay. If no, it's fine, but I need to know why. Okay, and then one more from last class's topic, and then we will move on. So we still get to use the same old derivative rules. Power rule, derivative of the constant is still 0. To do this, you're going to need the product rule, but the one step that's different is everywhere I'm taking the derivative of y, I need this y prime. So I took the derivative of y here. When I do the product rule, I'm going to take the derivative of y, x times y, so take the derivative of x with y left alone, and then plus the derivative of y with x left alone. Every time, not most of the time, not 99% of the time, every time you take the derivative of y, you need a y prime. The one exception would be is if it was with respect to y, which I cannot think of a single case where that ever happens. Okay, and then we just need to make it look like this. That's what they were asking you to do. But in the scoring guide, it appears that they're pretty consistent, that they'll give you one of the 2 points if you have both of those. So even if you run out of time, that point shouldn't be too hard to get. But you might want to distribute the 3 first step. You don't want to skip too many steps. That's really the point of this question, is for you to show. So I'm going to subtract that over and then subtract this over. That way everything on the left has a y prime and I can factor it out. And then you can undo times with divide. Again, not the easiest simplifying, but they all pretty much simplify the same way, so that makes it feel a little bit easier. And again, if this didn't look identical to this, I would just make one more step and make it look exactly the same thing. I don't know how picky they are. Okay, anything about that one that seems harder than the rest? Okay, this would be a good time if there was something that came up in there that you might want to word to yourself. Write yourself a quick note or two. Generally speaking, we won't talk about implicit again until the review, where I'll give you a few more questions to remind you to be on the next test. But we are basically going to be focused on related rates for the next few questions. Related rates do have a little bit of geometry mixed in there, which I know that you guys like, and related rates honestly is probably my favorite calculus topic. These are some really interesting real-world questions, and with just a tiny bit of calculus, we can solve some stuff that basically is just not possible to do with just guess and check and brute force. So one thing that can be difficult about these, and why these take more practice, is every question seems kind of different. So especially on our notes here, I'm really going to hammer in the structure of how I approach this question, because the structure from question 1 to 2 to 3 to 4 should all be very similar. So we need to always make sure we read the question carefully, identify any given information. Drawing a picture can help sometimes. Define your variables. So if they tell you how big the radius is, say r equals whatever, you're going to have to come up with an equation that uses those variables. And then probably the most important piece is this one right here. Related rates, we will be taking the derivative with respect to time. So we're not taking the derivative with respect to x anymore. With related rates, what's changing is time. As time goes on, stuff is changing. So what that means is, now every time I take the derivative of something like r or v or a or anything that's not t, I'm going to need an r prime, a v prime, and a prime, just like when we took the derivative in implicit. When we took the derivative of something with a y with respect to x, because these variables didn't match, we needed a y prime. Now when we take the derivative of these, unless it's time, which I can't think of when it would be, we're going to need to follow through on the same thing. Okay, and then we're going to plug all that in, and then sometimes we're going to be able to solve for what we want, and sometimes we'll have to do a little bit more digging to get enough information. But let's go ahead and just dive into the questions here. Okay, so question 1, we've got a snowball, and what kind of geometric shape would a snowball be?
Sphere.
Okay, it's a sphere. And one of the values they give me is that it is melting at a rate of 10 cubic feet per minute. Well, when I hear 10 cubic feet, is that like area, volume, or a length? Good. Volume. And because it's per an amount of time, per minute, this is not volume. This is the rate that volume changes. So not V, but V prime. That's how the volume is changing per time. Or, that's the same thing as saying dV dt. You need to know that those are equivalent. I just tend to use the prime symbols because I think it's a little cleaner looking. Okay, it wants to know what is the rate that the radius is changing. So this is what we are trying to find. So what am I solving for? What variable? Very good. So dr dt or r prime. Not radius, because the rate that radius is changing. That's how I know it's an r prime and not an r. And then you have to be told when. So it varies. If it's a big snowball, the volume goes down faster. If it's a small snowball, the volume is going to be less, so it's got less to decrease. But when the radius is 2 feet. Now I actually do have one mistake here. It's the V prime. By saying that it's 10 cubic feet per minute, that means that it's increasing and it's supposed to be melting. So this word melting makes it negative. The volume is going down as the time goes on. So I skipped a picture. We don't need a picture to see what a snowball looks like. I defined the variables. It says we need to come up with an equation that relates these variables. So if the thing is a sphere and I know something about volume, and I know something about radius, then the formula we want to use is the volume of a sphere formula, which is 4/3 pi r cubed. Your AP exam does expect you to know some geometry formulas, but not this one. Anytime they ask you to deal with the volume of a sphere, they provide the formula in the question. But notice, I've not really done any calculus yet. I mean, I guess knowing this notation's a little bit of calculus, but at some point, you need to take the derivative of the equation with respect to time. So, the derivative of v would be 1, but v is not the same thing as t. So, it would be 1 v prime, or 1 dv over dt, if you rather write it that way. What about this one? What would that look like if I did the power rule? And I just took the derivative of r. Was it with respect to r? Then I need an r prime too. And then this is best case, because they told me this value. This is a number, this is a number. They told me this value. The only thing they didn't tell me was r prime, which kind of makes sense, because if they had told me r prime, there wouldn't be anything to do in this question. That's what we're trying to solve for. So this ends up being 16 pi. I could divide both sides by 16 pi, and I don't know, I guess I could at least reduce the fraction. Looks like the rate that the radius is changing at that exact instant would be -5 over 8 pi. And then what kind of units would this be? Is radius going to be feet, feet squared, or feet cubed?
Square.
Feet squared is when you're talking about area. Volume is when you're talking about volume. And linear would be for lengths. So the radius could be feet, but the rate that the radius is changing needs to be feet per a time. So if that's in minutes, that's in minutes. Now, the next question is not going to have anything to do with a snowball or a sphere. But what's going to be consistent is we're going to read through the question. We're going to try to identify all the given information, like I did here. I'm going to think about the geometric shape and a formula that tries to tie this stuff together, like I did here. This is calculus, so obviously we need to take the derivative at some point. Then you start plugging in the stuff that you have, and then solve for the thing that you don't have. And that is the structure that all of these will need to take. Okay, anything you want to ask about number 1 before we try number 2? Number 2 is probably the hardest one on this worksheet too, but y'all need to see what the harder ones look like. Okay, so number 1, I didn't really need a picture because it was just a snowball, but this one, a baseball diamond is 8,100 square feet. So I am going to draw a baseball diamond. And label that information. Okay, CJ is running from first base to second base, so he's somewhere over here. And he's running at a speed of 25 feet per second. Now notice, unlike the last question, I can't say R equals this, and V equals that, and R prime equals this. All I can really do is put it on the picture where I think it goes. Finally, how fast is he moving away from home plate? So if this is CJ, I'm interested in from him to home plate, how fast is he moving away? So how many feet per second? This distance. That's what it's asking. and at the moment when he is 30 feet away from first base. Because if he's right on first base, this speed is different than if he's almost to second base. So when this length is 30 feet. Okay, I think I've extracted all the information out of the question, but sometimes I do have to read it a second time to try to get more, but I think we're good on this one. And I'm trying to find this length. So what geometric shape can we use that would include something about this length? Okay, the geometric shape is the right triangle. Good. And what is a geometric formula that includes right triangle? Pythagorean theorem. Pythagorean theorem is the most common type of related rate. At some point, you've got to do some calculus. So the calculus is going to be taking the derivative of the geometric formula with respect to time. So when I take the derivative of a squared, I can do the power rule, but a is not the same thing as t, so I need an a prime. When I take the derivative of b squared, I can just do the power rule, but b is not the same thing as t, so I have to include the b prime. Same thing with c squared, becomes 2c, c prime. This a prime, b prime, and c prime is very, very similar to what we did with implicit. Y was not the same thing as x, so we included y primes. A is not the same thing as t, b is not the same thing as t, c is not the same thing as t. So we have to include those pieces. Now this part's optional, but most people like to just divide everything by 2. Since everything has a 2, you can just make the numbers a little bit smaller. Okay, and then we start plugging this stuff in. So I'm looking at this right triangle here. This side has to be called C because it's the hypotenuse. The other two can be A and B. Doesn't matter which one's A and which one's B. But I start plugging this stuff in, and do I know the length of A right now? Okay, so let's leave A alone. We do have enough information to find it, but I don't know it right now. What about A prime? How come? Right, A is not changing length, so the rate of change of A is 0. It's not ever changing a length. Looks like B is 30 feet, and B prime is 25 feet per second. C, do I know the length of C? Okay, then I need to leave it a C. And do I know C prime? No. In fact, C prime is what the ultimate goal of this question is, so that's going to be the last domino to fall. So unlike question one I plugged in my knowns into the equation after I took the derivative, and I had everything except what I was solving for, so I was on my way to the answer. This question's a little bit harder because even though I don't have to know A here, I guess, because anything times 0 just goes to 0 anyway, I can't solve this for C prime until I know how big C is. So we got to do a little bit more work to think about how big C is. Well, we haven't used this, that the baseball diamond is 8,100 square feet. How can we use that to help us out here?
You take the square root, you get the side root.
Okay, so the square root of 8,100 would be 90 by 90 by 90. So I could have used that to figure out that A was 90. I just didn't really need it there because it was getting multiplied by 0 anyway. But knowing that A is 90 and this is 30, how does that help me find C?
You can just use the regular Pythagorean theorem.
Right, so you have to focus in a little bit more. Now in that right triangle, I know one of the legs is 90. I've known one of the legs is 30. and c is the square root of that. And we're not going to worry about simplifying or anything. We'll just leave it as is. This is the square root of 9,000. So now that I know what c is, I can plug that in. And now I've got an equation that the only thing I don't know is c prime. So now I just need to solve it algebraically and I have my answer. This goes to 0. Let's see, 30 times 25 would be what? Very good, 750. Notice I did keep up with the units here. Actually, I guess I should keep up with the units there too. This would be feet squared per second. And then if I divide this over, and it was in feet, feet squared divided by feet would leave you feet, still per second. And again, I'm not going to worry about simplifying. 750 over the square root of 9,000. Which is almost 8 feet. Yeah.
So do you have to put the keep up with the units for the whole problem, or can you spread it out?
In theory, you can put them at the end. The only problem is you guys forget sometimes. So.
Can't
That-
you simplify the square root of 9,000 to 30 square root 10?
Yeah, you can.
Cancel out the 30, just keep it.
You could, and you would maybe need to as a multiple choice question. He was asking if we could simplify this radical and then use that to simplify the fraction. And the answer is yes, but in a free response, just leave it. You don't have to do any arithmetic. If it's multiple choice, simplify as needed, but I'm not really concerned about that right now. So, again, you probably not see any more baseball questions, but I drew a picture. I labeled all the information. I thought of a geometry formula that combined all that information. I took the derivative of that with respect to time. Because of the respect to time is why this stuff is highlighted in there. I plugged in the stuff that I had. I realized I was still missing c, so I had to do a little bit more work out to the side to solve for c. But then as soon as I plugged that in, I had one equation, and the only thing that I didn't know was what the question was asking for. So after a little bit of solving algebraically, I can tell you how quickly that is changing. Okay with that one? All right, so question 1, we solved sphere. Question 2 was Pythagorean theorem. And then question 3, we've got a stone dropped into Lake Fayetteville, causing concentric circular ripples. That's when you have circles perfectly inside of another circle. The radius is increased by 2 meters per second. So what is 2 meters per second? Very good. Not the radius, but the rate of change of the radius, so r prime. How fast is the disturbed area growing? So what am I solving for? Very good. The rate of change of area when it has a radius of 5 meters. I have a picture, although I don't know it did anything. I've defined the variables. Now I need to think of a geometric formula for this type of shape that combines these type of variables. So, what do you think? Okay, what about pi r squared? Pi r squared is not an equation. Okay, equals the area. Area is pi r squared, area of a circle. Now, when we take the derivative of this, what is the derivative of a? Good. What's the derivative of pi r squared? Very good. When we took the derivative of a with respect to time, we needed an a prime, and when we take the derivative of r with respect to time, we need an r prime. This I don't know, because this is what I'm trying to figure out. 2 is just a number, pi is just a number, R I know, R prime I know. Now here is one benefit, and I'm guilty of this as well, but one benefit of not writing the units versus writing the units. If you write the units, notice R, I didn't just say it was 5, I said it was 5 meters. R prime, I didn't say it was 2, I said it was 2 meters per second. Then when you multiply, 2 times pi times 5 times 2 would be 20 pi. But then also the units, meters times meters per second would be meters squared per second. How that should be helpful to you is it should help you catch some of your mistakes. If this was meters cubed, that doesn't make sense for area. Area is always squared units. If it was just meters squared and not per second, that would also give me cause for concern, because this is supposed to be a rate, so it's changing per an amount of time. So keeping up with the units should give you a little bit more confidence that you've got all the pieces you need. Okay, so number 1 was the sphere, number 2 was Pythagorean theorem, number 3 was area of a circle, and then number 4, all edges of the cube are expanding at a rate of 3 centimeters per second. So number 4 is a cube. How fast is the volume changing? So what variable am I solving for? V prime. When the edge is 1 centimeter, and I guess you can call it, you can label whatever variable you want to, but most people call it an S. The side is 1. Okay, and I also know this. The edges of the cube are increasing at a rate of 3 centimeters per second. So that would be S prime. Well, what is the formula for volume of a cube? Side cubed, or length times width times height, but in a cube all of them are the same, so you don't need to call them length, width, and height. You can just call them side, side, and side. You've got to take the derivative of this. B prime 3s squared s prime. B is not the same as t, so I need a v prime. S is not the same as t, so I need a s prime. This is what I'm solving for. This was given to me in the question. Oops. Squared 1 centimeter for s, and s prime was given to me in the question. So what is 3 times 1 squared times 3? Okay, and what is centimeters squared times centimeters divided by seconds? Okay, and does that make sense for v prime? Volume, always cubic units, so that makes sense. V prime needs to be per time unit too. So totally different question. Picture surely didn't hurt, but I defined the variables. I thought of a geometric formula that tied those variables together. I took the derivative of the geometric formula with respect to time. I plugged in the step that I had, I solved for what I didn't have, and that was what the question was asking for. So completely different shape, but same structure to the question. Okay, anything you'd like to ask about number 4? Okay, then moving on to the last 2, and this is kind of like 1.5 because it's the same question, we're just going to change one number. But when we move on to the other worksheet in just a second, the best thing you guys can do for yourself, especially on questions that you need a picture for. Some of them you don't need a picture for, but the ones you do need a picture for, don't try to make your picture so small that you can't work with it. You got lots of space. We've got a building. We've got a ladder that leans against the wall. The base of the ladder is being pulled away at 2 feet per second. I'd like to know how fast the ladder is falling down the wall. So how many feet per second is a ladder falling down? If the ladder is 7 feet away from the wall. Okay, and then we're going to do the exact same thing, but if it is 15 feet away from the wall. So make your picture big enough that you can see and work with it. I guess I know the ladder is 25 feet. And I'm pretty sure I've labeled everything now. So what is the geometric shape we're working with in this question? Okay, and what's a formula that will combine this type of information with the right triangle? The most common type, Pythagorean theorem. Take the derivative with respect to time. So you need a prime, a b prime, and a c prime. If you would like to divide everything by 2, go for it. It's optional. You could save that for later if you wanted to. And then let's start plugging in and see if we have enough information here. So this side has to be c because it's the hypotenuse. The other two, one of them just needs to be a and one needs to be b. Call them whatever you, it doesn't matter which is which. Looking at this, I don't think I know the length of a, at least not yet. A prime is what I'm trying to solve for. So that'll be the last domino to fall. B, do we know the length of B? 7, so we can plug that in. Do we know the rate of change of B? Okay, do we know the length of C? 25 feet, this ladder. And how fast is the ladder changing in height? Now what we're trying to find is this. How fast is the ladder falling down the wall? 0. Your ladder is not changing size. Your 25-foot ladder is a 25-foot ladder. So if I'm trying to solve for a prime, I can now see the only piece of information that's going to keep me from getting my answer here is knowing a. I've got to come up with this length. Well, like the baseball question, again, this is kind of, yeah.
Whenever you're writing for B, would it always be, like since it's being pulled away, would you have to write negative or can you just say 2?
There are times that you do have to worry about that, but not with this question. Specifically, like, what gets a little tricky here is sometimes the wording of what it wants you to find. When I get done solving this for a prime, do you guys think that the answer is going to be positive or negative? Negative. Because it's going down so much feet per second, so the answer is supposed to be negative. But in a multiple choice question, the answer might be positive if it says something like, how fast is it moving down? Because that's like implying the direction already. So that part you have to be careful about. But okay, so again, my picture is a little bit busy here, so I'm going to have to look at it for just a minute. But eventually I should see, well, wait, I've got a right triangle. I knew this length was 7 feet. I know this length is 25 feet. So can I just use Pythagorean theorem to figure out how big a is at that time? Because that's what I need. Do y'all know this Pythagorean triple?
24.
It's 24. And you could use Pythagorean theorem if you needed to. So once you unlock that, now the last thing to solve for was the whole point of the question. And notice I didn't keep up with units, so I have to do a little bit more work here. But this was the rate of change of a length. Actually, I did keep up with it. I just thought about it at the very beginning. So, feet per second. And again, it's a little tricky based on the wording. When it says how fast is it moving down, I probably should just say 7/12 and not say negative because it's implied that it's going negative. But okay, last one before I ask you to start practicing them. So all the same information, but now let's not make this 7 feet, let's make it 15 feet. Well, the picture's still the same, still going to be Pythagorean theorem. You're still going to take the derivative of both sides. You're still probably going to divide everything by 2 now or later. The difference is now B is 15 feet. The ladder is still 25 feet. The rate of change of the ladder is still 0. But A has to change too. Does that make sense? If I'm changing this from 7 to 15, then A can't be 24 anymore. So changing this length changes this length because it's further away. It's further in time. The ladder has fallen further. So we would have to resolve for A, and it comes out to be 20. But otherwise, it would work out similar to how we did part A. So again, before we started these notes, I told you these were going to take more practice. So the important thing here is no matter what the question is, whether it's a quick question or a longer question, consider making a picture, define all the variables, whether that means throw them on the picture or label what they are. Come up with a geometric formula like Pythagorean theorem, like area of a circle, like volume of a sphere. Take the derivative of it with respect to time. The with respect to time is important. Plug in all the information that you have. If you're lucky, you can solve for your answer. If you're unlucky, you have to do a little bit more work to find one more piece like we did there, and then you can solve for your answer. So that's the part that will be consistent. Okay, so let's see how it goes. So on this other handout, this one I do have to warn you guys about. I would strongly suggest that you do this on a separate sheet of paper. If you try to cram your work in this little bitty space here, if I can't read it, I'm not going to try to read it and get a headache. That is the risk that you run if you try to do it on here. I would do it on a separate sheet of paper. But the first 6 have the answers at the bottom of the page. So once you work question 1, if you don't end up with 8 pi square feet per second, then you need to work with me and work with your neighbor to get that figured out before you go to number 2. So even though this is not going to be due next class, you've got 40 minutes, so you should make a fairly good sized dent in it. And then the only homework is turning in the book assignment. That was your homework last time, so I need that by next Tuesday.
It's past due.
Stuff from Unit 2?
It was like last week, Sunday.
Was it before the test?
Possibly.
I don't take work once we move it past the unit. I've said that multiple times. Late work has to be turned in before the test. I would say start off with the little words that you want, but when you get stuck, I well, I can tell how much work you should. So as long as you're not taking any unspiritual tests. If you just write the answer down, that's not gonna work. If I can see you got that answer and it's like you took the derivative right and you just plugged it in and did it in your head, that's fine. That's fine. get past this page. These are all AP questions, so most of them are multiple choice, and I've got the answers, but if you just give me the answer, I'm not gonna give you the answer out because I don't know that you even tried it. pile, so it's a cone.
Oh, then what's the?
Volume of a cone?
Yeah.
1/3 pi r squared h.
The one that's on the formula sheet.
A formula sheet of the ones you have to memorize.
Oh, okay.
I'll show you the trick where you can, like how you can figure that one out without memorizing it, but.
Okay.
See the first one? Answers are at the bottom. You did 8 pi. You got the first one? Okay. Okay, as far as I could tell, it didn't look like anyone was stuck with question 1. If I'm wrong, please call me over and let me help. And I don't want to give it away, but question 3 takes a little bit more thinking behind it, but it's good for y'all to see where you might get stuck before I just tell you. So. Yes.
On number 3 where it says R equals H, would that mean the volume formula is 1/3 pi R cubed?
It could be, or it could be 1/3 pi h cubed. I think if you do the r cubed one, once you take the derivative, you're going to realize that you don't have an h prime to solve for, which is what you're looking for. So it's better to change them all to h's. Okay, if you have not gotten the correct answer to 1 and number 2 and you're stuck, then please let me know so I can come help. Great. So, in place of B prime, you need to put an 8. In place of R, you need to put a 10. And then as soon as you plug those in, you're going to have the formula that's ohming this in R prime. So now solve for R prime. And then that should be your answer. Number 3. Where did you get stuck? How about that?
Were these the right things? I don't think so.
This is not B prime, this is just the formula for, oh, yeah, that's just the formula for B. That's not B prime.
Well, what are you solving for?
I
It's
don't know.
already filled.
Once,
We're gonna change it to.
so it wants to know H prime. Okay, but they also tell you that R is equal to H for this one.
Okay.
So instead of calling this R squared times H, you could either call it R cubed or you could call it H cubed.
Okay.
And that's actually kind of nice, because without that, you'd have to do product rule, and you'd have to know a whole lot of different things. Of course, you guys need to make sure you have your work somewhere. If you're doing this on a separate sheet of paper, make sure that you attach it when you turn it in. And especially once you get past this front page, I don't know if you guys will get past the front page in class, but once you get to the second and third page, all of these are from past AP exams, so they're multiple choice, and we do put the answers to them on the very back page, but if you don't have work that goes with an answer, that's not going to be worth any points. So. Has everyone had time to try question 3? Okay, I assume that's one that some people would like to discuss. Yes? Okay. Just making sure, because if you don't need it, then that's fine. We could look at something else. Okay, so number 3 says a gravel is falling into a conical pile, so that's going to be a cone. And then it goes on to talk about the volume of a cone. So they do expect you to know this formula, 1/3 pi r squared h. And I will show you some tips next class on how you can figure that one out without memorizing it. But the info that's given to us is the volume is changing at 100 cubic feet per minute. I need to find the rate of change of height. So H prime is what we're looking for. Specifically when the height is 10 feet. And then they said assume for this question that R equals H. So if there's two paths you could take here that are not wrong, but they're just not helpful. You could start to take the derivative of this, and you would have to use the product rule here. You'd have to take the derivative of R squared with H left alone, and then the derivative of H with R squared left alone. And that's not wrong. In fact, that's almost what I kind of hope that you would do, because I'm hoping that you guys see that that's product rule and apply that. The problem is they don't tell me anything about R. I don't know what R is. I don't know what R prime is. I don't know what the H prime is. There's too many different things, and I don't have enough information to go and solve those. So even though that does equal the derivative, for this question, since R equals H, you could say, instead of saying H, let's call it R. And so I would also understand why you would have this, and when you take his derivative, you would get that. But now this is a different problem. One is, I still don't know what R is equal to. Well, actually, I guess I do. If R equals H and H is at 10, then R is at 10. I guess I do know that one. But I don't know the rate of change of radius, and I don't have enough information to solve that. And most importantly, I'm trying to solve for the rate of change of height. And if I do it this way, I don't even have an H prime. So instead of replacing everything with R's, we could take the formula and replace everything with H's. So this is like H cubed. Then when you take the derivative with respect to time, the only two things that you need are V prime, which was given to you, H, which was given to you, and H prime, which is what you're searching for. So this would be feet per minute. So what makes this one a little bit harder is at first glance, you don't know if you should just take the derivative of the whole thing and do product rule, but when you try it, you've just got too many different things that you can't solve for. If you replace H with R, you can try it, but then you realize that you don't have an H prime to solve for. If you plug in H's for R's, then you're left with this guy, and he works out great. So part of what makes that question hard is, again, there's two things you can do that are not wrong. It just, you get stuck and you got to try something different. Okay, was there something more specific about number 3, or is that enough? Okay. All right, I'll still have almost 20 minutes, so try to get a few more done if possible, please. How do you know it's the same answer?
I guess it's not, I mean, I worked with something like that.
That's acceptable because they're the same answer. I think they rationalize.
Okay.
See, you have the square root in the denominator. It's fine in calculus. It's a big deal not to do that in trigonometry, so you think it a certain way.
Okay.
The only issue would be if that was a multiple choice question, making sure you know how to get to that to that.
Okay.
Also, I'm trying to make a list of the formulas that show up that they expect you to know, like area, circumference of a circle, area, perimeter of a square, volume, surface area of a cube, volume of a cone. Have y'all seen any others yet? Yeah. I will put it down because you never know. Okay, as you guys see other questions with other geometry formulas they expect you to know, please let me know, even if you know them, because again, I'm going to try to get them all typed up on one page for you, to at least have one place to look at. And what did I get? Is that what you got for an answer, you mean? Well, I think what they're doing here is they're probably simplifying this radical and then rationalizing, multiplying the top and the bottom, because they're radicals in the numerator. What I would do if I was you, just type that in your calculator, get a decimal, and then type this in your calculator, make sure it's the same decimal. And then in a free response, that would be perfectly fine. And multiple choice, you would have to think about what you could do to that. So.
Yeah.
Out as a decimal, and I'm just curious if I'm just data as a decimal or
Probably not. I'd leave it as a square root. Just leave it as square root of that.
Okay.
I think a lot of people are getting an answer that looks a little bit different than this one. And I think what's happening is you guys are not simplifying your square root, and then you're not rationalizing. They're rationalizing.
No,
I don't care if you do that at all. The only concern is if this was multiple choice, you need to be able to confirm your correct answer to that correct answer. So, but I think leave it a square root and then just compare the decimal. Make sure they're the same.
Still nothing to mess me up with? Okay. Okay.
We're given the sidelines, and those are like the A and B, and those are like the because that's like 3 centimeters.
Okay.
And then.
3 centimeters per. Okay.
And B is just. And then I found C, but I found that's if I make But then whenever I solve for it, I don't get that, which would mean maybe. Cause this would be like 15 plus 15.
A is fine, B is fine.
I'll do the units at the end, so then I have 30.
15 centimeters squared.
Yep.
So I got figured out all like that stuff.
You know what the front page?
Yeah.
Okay.
And then how do I take the without, do I have to multiply by 1?
Well, what you hope for is you hope that they tell you R and H are the same. It's a little bit easier. When they don't, the only thing that you can do is take the derivative, but you're going to have to use product rule. It's R squared times H. So one time I took the derivative of R squared with H left alone, and one time I took the derivative of H with R. Yeah, I don't know. Most of the time, when we create technically rational rounds, but in your thinking, we don't bother to rationalize. But someone might rationalize to make an answer. You still need to be able to do it, but you don't have to do it.
Okay, we're down to about 5 minutes here. So again, let me be clear. This you do not need to do for homework yet. I guess if you feel really overwhelmed, it might help if you do 1 or 2 questions just to force your brain to think about the process again. But we will spend another class or maybe even 2 on this topic so that they get easier and easier. So I will ask you to do all of number 41 eventually. So I guess if y'all don't have anything going on in one of your classes or during advisory or something, it's not going to hurt you to move on, but you don't have to move on. The only thing I have to have from you is the book work we did last class. I need that in Google Classroom at least before I see you next time, which is next Tuesday. So y'all should be done with that anyway. But if you don't have it in Google Classroom by next Tuesday, then it'll be late. And then I guess the last thing, while you guys are packing up here, have y'all heard this saying before, the daily meme? Someone goes off on a tangent. Do you understand like what that means with math? Like math is where that saying came from. So like you're on the conversation, but then at some point you just go off randomly. So that's where that saying came from. Sure.